randomness does clump. But remember that it doesn't predict that a second outcome is more likely than the first. They're truly independent. So random clumping, usefulness, random clumping wise, it's best to look back at a data set to decide if it was a random data set versus trying to predict what's going to happen next, which is next to impossible. So I love the idea that if I saw a 2, I'm pretty likely to get a 2 on the next time. You're also twice as likely not to, because there are 2 other options besides 2. So there's 2 ways to think about it, and be careful. Vince Larisha made that mistake when he thought 12 tails in a row, I'm betting on heads. I'm like, dude, it's just as likely to among tails. Yeah. Right? So the whole clumping idea is after the data set's done, being able to look back at it. This is how they were able to discover in 2010 that the elections in Iraq, the first democratic elections that were held in Iraq, were actually forged. They were faked. The ballot boxes were stuffed. Because the data, the numbered ballots that should have had a measure of randomness in the numbers were too far off what should have happened. So it was after the data set was, we'll study that in 244. That's something in 244. You look at a set of numbers that comes in. Like for example, your checkbook. If you guys still have checkbooks, the check numbers on your checks, you know, 123, 124, 125. There's a certain percentage of ones in total you should see in any string of numbers. A certain percentage of 2s, a certain percentage of 9s, a certain percentage of 0s. If you deviate too far from that, you start wondering if people are fixing the numbers going in because they're not random enough. There is a random assignation to even numbers like that. And that's what's so interesting about post hoc analysis. Seeing a chunk of data come in and then trying to decide if it's random or not. Is that fair?
Yeah.
I love what you're saying. Love what you're saying.
What's that word? Acid or something that when some like
Asymptotic?
Asymptotic.
Yeah, asymptotically. Exactly. But the thing is, it's best to look at it afterwards and then say that doesn't look random enough. That's why I liked comparing your guys' data to the true random curves and being like, look, you guys aren't too far off of that. You did a pretty good job of randomizing. Yeah? Make sense? You ready? We've got time for like 3 more games. Then we'll finish.